Hello, back looking at related rates using Pythagorean theorem and those related rates questions. As I said previously in the other video, you're not going to see related rates questions that tell you use Pythagorean theorem. You're going to have to be able to figure that out on your own. And it's assumed that you know how to do it and you understand it enough to be able to apply it to this situation. This is a pretty classic question. I know it's kind of lame, but you're going to see it. I don't care what calc class you're taking. You have a ladder. It's sliding down a wall. Okay, so a ladder 20 feet long is sliding down a wall. So the bottom of the ladder slides away from the wall at a rate of 2 feet a second. We want to know how fast the top of the ladder is sliding down the wall when the bottom of the ladder is 12 feet from the wall. So let's dissect this question. So what we have is we have a wall. Okay. We have a ladder. And that ladder is sliding down. Okay, so he's going down the wall. And so here's the ground down here. So let's put the ground. Okay, so there's the base of the ladder on the ground. So hopefully you kind of visualize this situation. What happens is this thing slides down, this thing slides out. Okay, but you can see the construction of that right triangle that's now formed. Okay. So the interesting thing about this question though is that the ladder doesn't change length. And that's often forgotten. And so that's going to factor in just a moment. We know that it stays a constant 20 feet. So let's kind of list what we know. So we know the length of the ladder. So let's give these guys names. Let's go A, B, C. So we know that C is 20 feet. We know that the ladder slides away from the wall, so it's going this way. So we know the change in the A, so dA over dt, we know that that's a positive 2 feet per second. Okay, so we're trying to find dB over dt when the bottom of the ladder is 12 feet from the wall. So when A is 12. So there's our situation we need to look at using Pythagorean theorem. So let's list the Pythagorean theorem. Now at this point we can differentiate. You got to be careful of throwing in numbers too early before you take the derivative, but you can put 20 in here right now. Okay, you can insert that 20 because it is a constant and it's remaining constant. But I want to show you that it doesn't really matter. It's always a mistake if you put the numbers in too early. If you put them in too late, you can generally catch it. So I'm not going to do it right away. So we're going to differentiate here. So we're going to do 2a dA over dt plus 2b dB over dt equals 2c dC over dt. And what you'll notice is this is 0 because the ladder doesn't change length. Okay, the ladder is moving, but it's not like getting bigger or smaller. It's not like an extension ladder that's going to kind of go flexible. Okay, it's just at a constant rate. And so that makes this entire thing turn into 0. And then we got to think about the situation that we have. So obviously the 2's are there. We know A in this instance is going to be 12. dA over dt, that's 2. B, we don't know B. Okay, and so we need to figure out what B is. So if you think about the certain situation at hand, you know that this is, at the moment we're interested in, this is 12 and this is 20. So you should be able to do Pythagorean theorem to figure out the length b. Or in this case, realize it's a Pythagorean triple, and so its length is 16. So this is 16, and dB over dt is what we're interested in finding. So it's totally okay, he's still around. And now we just need to solve. So this turns into 2 times 12 is 24, so that's 48, plus 32 dB over dt equals 0. And so when we subtract and then divide, we're going to get dB over dt is negative 48 over 32. Let me see what they have in common. They have an 8 in common. Anything else? Oh, they got 16 in common, so that turns into negative 3 halves feet per second. Now let's think about this scenario, and hopefully as you do these questions and you kind of think about, I know this is a weird real-world situation, but you can look at this and say that you know something, okay? Like this being negative, generally the first time you see it is scary, but let me kind of help you out. Realize that this thing is moving down, okay? And so that's a negative rate. Okay, so when things are moving down, it's negative. And so as this moves out, okay, this is going positive, this is going negative, okay? It's the same type of question when you did acceleration and velocity and you threw a ball up in the air. Well, when it's going up, it's got a positive velocity. And then when it starts going down, it's got negative velocities. So that's the same idea here. As this thing travels down, you have a negative rate. Negative 3 over 2. It's a good answer, okay? So hopefully this helps out. Hopefully you realize the structure. You got to draw a picture. I highly recommend listing out the information from the original question. Kind of what you know, what you're supposed to find, okay? Some teachers and some students like to kind of figure out the scenario first, and that's okay. Other kids kind of do it the way I do, where you differentiate and then you plug in and realize that. The only caution is 2 ways. One, don't plug in numbers too early because you could be messing up the question, or you might be taking the derivative of something that you don't want to be taking the derivative of. So you gotta practice these and realize how to do the type of problems, because once you kind of get clicks, you'll be fine. Okay, send me a message, Schoology, email me. I don't care who you are. If I have you or not in class, I'll help you out. Good luck.